Hello. Now, let's put our trigonometric functions in the unit circle into practice. So our steps in general are going to be draw the unit circle, get the reference angle using a model triangle, and we're going to talk about a model triangle in a minute, but we know about our reference angles, and then use the quadrants in our unit circle to figure out what the signs of our answer should be. Now, the first two of these questions are possible to do directly on your calculator. But we need to follow out the steps so that we can do the more difficult questions, and these concepts of the unit circle and dealing with complicated angles will be built on later. So it's important that even with the simpler versions of these questions, that we do them out the long way so that we have these steps really solid in our minds. Now, but you can by all means check your answers very easily using your calculator. Now, if we're asked for sine of 130 degrees, we are going to, first of all, draw our unit circle. The unit circle is not to be anything fancy. Very crude circle, basic shape of a circle. And then where does my line need to go? I'm starting at the positive x-axis. I know that. And I'm going to rotate around anti-clockwise. That's how my angles always work. But where should 130 go? Well, I know up here, if I rotate through 90 degrees, I'd end up here. If I rotate all the way to here, I'd end up at 180 degrees. So I'm somewhere in the second quadrant. So I'll just draw my line in. I don't know exactly where that is. I don't need to have a perfect picture in my mind of that, but that angle there is going to be 130 degrees. And now I need to figure out what sine of that is going to be. Well, I know that sine of that is the y component, is the height at that point, because I know sine of my angle is my y component. I know that from my unit circle, and that's going to help me figure out things as I go forward. So cosine would be the x component, sine is the y component. My next job then is get the reference angle using a model triangle. Well, I have my angle that I'm going up from the positive x-axis, but I know that to get my reference angle, I'm going to be looking for the angle going up from the nearest x-axis, which is this angle in here. So what's that blue angle going to be? Well, I'm going to draw a model triangle, which just means I'm going to draw a triangle with roughly the correct proportions and use that as a guide for myself as to what I need. So I'm looking, so my blue angle, my reference angle, how am I going to figure out what it is? Well, if I rotate all the way around from the x-axis down to the negative x-axis, I'd have gone through 180 degrees. Well, I've gone through 130 degrees. How much do I have left to go? How much must that blue angle be? So my blue angle here, would be 180 minus 130 would be 50 degrees. So my reference angle, this angle in here, is going to be 50 degrees. And now that is going to be either reference angle that is connected to sine of 135. So sine of 50 degrees would get me to the same height as sine of 130 degrees. So they are not quite equivalent, but they are relative to each other. Now, I know that I now know my reference angle is 50 degrees. So what I'm going to do is find out what sine of 50 degrees would be, because that will get me to the same height. And then I'm going to use my quadrants to figure out what the sine should be. So sine of 50, when I put it into my calculator, when my calculator is in degrees, is 0.76604. So this is my sine of my reference angle, and now I'm going to use my quadrants to figure out what the sine of 130 is going to be. So sine of my reference angle gives me 0.7660. And am I going to have a positive or negative sign when I'm in the second quadrant? Well, I know that the sine of my angle is the y component, and my y component is positive in the second quadrant. So this is going to have the same sign as my reference angle. I'm not going to have to change this to a negative. If I was down here, if I was down in the third quadrant or in the fourth quadrant, the sign would be negative because the y would be negative. But because I'm up in the second quadrant, my sign is positive. So that is my first job done. So I got my reference angle, and then I used my quadrants to figure out the signs I needed. Now, next bit, what is cos of 100 or 210 in surd form? If I see the word in surd form for an angle, I'm immediately going to open up page 13 in my log tables and look at the table on page 13 and see if I end up with any special angles. So I'm tipped off here because I'm asked about surd form that I might be dealing with a situation where I'll get a reference angle of 30, 45, or 60, because surd form tends to come up with our 30, 60, and 45 degree triangles that we meet on page 13 in our log tables. But first job, let's draw our unit circle. Again, no points for art here. We're just on a basic circle to keep track of what we're doing. Now, where is 210 degrees? Well, rotating all the way around to here is 180. Rotating all the way down to the negative y-axis would be 270. So I'm in the third quadrant, somewhere in the third quadrant. So this is my angle of 210 degrees. Now, what's my reference angle going to be? Well, I'm going to look for where I have the triangle of the same proportions here. So I'm going to flip it upside down, or right side up, depending on your perspective. And I'm looking for my blue angle in here. It's going to be my blue angle from the nearest x-axis is that negative x-axis there. So I'm looking for my angle down past the negative x-axis is going to give me my reference angle. And this is a model triangle that I can use to help me keep track of what I'm talking about. And I know that because I'm looking for the cos of the angle, I'm going to be looking for my x distance here. So I'm going to have my x, my y, and I know in the unit circle my radius or my hypotenuse is going to be 1. Now, what's my blue angle? Well, if I rotate all the way around to the negative x-axis from where I start at the positive y-axis, I'll have gone through 180 degrees. Then if I go a little bit further, I go to 210. So in the third quadrant here, where I'm working, I'm going to go 210 minus 180 is going to give me my reference angle. So I have gone past the 180, and I'm going to end up at 30 degrees. So my reference angle, my blue angle down here, is going to be 30 degrees, and I am looking for my x component here. So I find out what cos of 30 degrees is on page 13 of my log tables. You can also put it in your calculator, but it's better to get it from the log tables so you're getting practice on that, and you will find that it's √3 all over 2. So I now know my reference angle is, cos of my reference angle is going to give me √3 over 2. And now I need to figure out my sine. So if I'm dealing with cos of 210, is cos going to be negative in my third quadrant? Well, I know that cos is my x component, and that is indeed going to be negative back here. I'm on the negative side of my x-axis. So I need to turn this into a negative. So continuing on now, for what values of theta from 0 to 360 degrees is tan theta equal to -1? First job, draw my unit circle. And where is tan theta going to be equal to -1? Well, the first thing to always recognize if they give you a whole number is that that's secretly a fraction. So tan theta could be equal to -1 all over 1, or it could be equal to 1 all over -1. This is where the two possible solutions can come from. We can also work that out using the unit circle. So where is tan going to be negative? Well, it's when x or y, but not both, would be negative. Tan would be positive here in quadrant 1 and in quadrant 3. It's going to be negative when x is negative here and y is negative here. So we're in the second and the fourth quadrant, and we can use that, we can figure that out by using our unit circle. So now what we're going to do is draw our reference. We're going to get our reference angle by taking either of these two situations. So we have our model triangle, and we're looking for our angle in here, our blue angle just as before, that angle there or that angle there from the nearest x-axis. And what do we know in this case? Now here we know that the ratio of our y's over our x's is -1 all over 1 or 1 all over -1. Now for getting the reference angle, we don't care about the signs. We effectively always pretend like it's in our first quadrant. So we just take the magnitude but not the direction of our numbers. So we know that tan for our reference angle, which I'm going to call alpha, is just going to be 1. So alpha, our reference angle, is going to be 45 degrees. Now that we've used our model triangle to figure out our angle, we now use what we know about our quadrants to figure out what our two possible angles are. So theta, if it was in the second quadrant, would be 45 degrees back from 180. Would be 135 degrees. Or if it was in the fourth quadrant, it would be 45 degrees back from 360 degrees. Now, those are our two possible solutions. Finally, if cos theta is equal to -1/2, what would tan theta be equal to? First job, we draw our unit circle. And where is cos going to be negative? Well, it's our x component, so it's going to happen in our second and third quadrants, where our x components are negative, or where we're going to get cos being negative. And then we can work out using our model triangle. We know we treat it like it's in the first quadrant, so we're going to have adjacent over hypotenuse is going to be our model triangle. So we know the cos of our reference angle is going to be 1 all over 2, so our reference angle alpha is going to be 60 degrees. When we get inverse cosine of both sides, we'll get 60 degrees. Now we use our quadrants. If we were in our second quadrant, we'd have our angle could be 180 minus 60. Or if we were in our third quadrant, it would be 180 plus 60. So then we'd be dealing with, if we get tan of our reference angle to figure out our final answer, we want to know about tan. We get √3 over 1, then tan of 120. We look to our quadrants, and that's going to be